Yeah, it is recording microphone now. Cool. Okay. All right. Hey guys, it's your boy Reese. I'm here giving you a tutorial talk. So, the first talk we're going to be going over, and this is the one for today, is going to be Unity and everything you need to know about Unity, just like the raw basics to get you able to do things and to operate inside of Unity. For anyone who hasn't messed around with Unity in a really long time, this is going to be for you. Or if you have messed around with Unity, but you need to get back into it, this is also for you. Okay. So we're going to start with a new project. And just a quick description before we go into this new project, just the Unity Hub. First off, I'll put all the links to where you need to download everything in the tutorial talks chat after this. Hopefully everyone has Unity installed. If you don't, go to those links. I'll pin them because they're very important links. And then I'm just going to walk you through what the hub is. So you have your projects, which is any games that you would have made, or prototypes or any of that stuff. They're their own project, and that is its own file with all of its files inside of it. A specific game would be a project. Like, for example, this was the one I made for the Spooktober game jam a while back under Trench 21. That is its own project. And getting into how that works is right here. But before we go to that, you also have Learn, which there are a bunch of project and tutorials that you can use if this wasn't good enough, or you just want to have more experience in different ways. Then you can look at, this one says it's a beginner project, take about 5 hours and 5 minutes to completely do, that kind of stuff. And it's more hands-on, like, hey, you don't know how to do X? Let's show you. Like, for example, if I was going to make a VR game, I think I would probably do this tutorial to figure out how VR games work. Although Unity has really good YouTube tutorials if you don't want to do that. Then the community aspect is just a bunch of links to different parts of the community, such as Unity Play, forums, blog, all that kind of stuff. And then installs is the different versions of Unity you have installed. So there are two different kinds of Unity right now. There's the 2019 versions and the 2020 versions. Those don't actually have anything to do with the years. Those have everything to do with what kind of Unity you're using. So 2019 version of Unity is the official stable Unity. So for example, people who know anything about Minecraft, that is the official Minecraft, what point, 1.8 or whatever they're at right now. That's what that is. 2020 is the experimental is the wrong word, but it's like snapshots in Minecraft. It's like all the newest stuff. There might be some bugs in it. We don't know. If you're just doing a really small game or goofing around, I recommend using the 2020s just because there's no reason not to, and maybe there's a new mechanic in there that you would find interesting. Although a lot of these differences are so minute that unless you really, really, really know what you're doing, you won't even notice that there's a difference. Especially, at least in my opinion. I have never noticed a difference between them, but I'm just checking to see if there's any people who are really good at coding or any of that stuff out there. And so if you're doing a big project or a big thing, then I would use 2019. Cool. All right, let's go to projects and open up a new project. So you have different template options here. So these are actually not important. The only two that are important are these two, and even then, kinda. So these are just templates. It's kind of like opening a Word document or a PowerPoint. You have your little design template you can choose from before you use it. And they just change the presets, but they don't change anything particularly. Everything you can do in the 3D, you can do in the 2D and vice versa. And then I'll get into what these are in a second. So don't worry about it. If you choose 3D and then you build a big game in 3D and then you go, oh my gosh, I need 2D. Don't freak out. You can change it really easily. It's not hard. Same with 2D. If you build a game in 2D and you realize, man, this should have been 3D, but I don't want to move all my code around, you'll figure, it's not hard. You can just enable and disable different things. So personally, I do everything in 2D because one of the things that 2D has enabled that 3D doesn't, and to my knowledge, the only difference is that 2D has sprites enabled. So you can have sprites, which are two-dimensional images, in your game. Versus in 3D, you can only do them as textures on 3D things. So I'd make a cube, and then one side of the cube would be the sprite I want, instead of just having a sprite freestanding. You can enable that in 3D. I don't know how, and I can't be bothered to look it up because I just can't be bothered. I'm lazy. So I personally go with 2D and then just enable everything into 3D mode, which is a really weird way to do it, but that's what I do. We're going to be doing 3D for this example. Down here we have the render pipelines, and then this is a bunch of like special stuff you don't need to worry about. But down here we have the render pipelines. So these are actually important, but they're only important if you're making a big time game, like a really big game. If you're making a small game or a demo or a prototype, they are not important at all. If you're planning on making something to like sell for like a $15 or $20 game, then you need to look into these because these are important. So render pipelines, there's just how the computer renders all the graphics of the game. So a high definition render pipeline is going to give you that really good crisp look, but you on your side need to be doing a lot of optimization because your game's going to look really pretty, but you need to make sure that everything is like super efficient as humanly possible. Otherwise, your computer's going to get really slow when it runs the game, and potentially when you're working on it in the scene mode as well. The other way around is universal render pipeline. It's not as pretty. You will only notice this if you're trying to make a really pretty game, like really pretty game. Otherwise, personally, I would go with universal render pipeline every time. But it makes everything run a lot faster, and the graphics are much more optimized automatically. So that's the one I would go with. And then just really quick down here, a couple of these are like little mini games and micro games that you have here that are just like I was saying earlier with the tutorials. They're exactly the same. It's like, hey, I don't know where to even start with an FPS. And it's like, cool, well, here's all the mechanics you would need for an FPS right off the bat, and it's free. And 2D platformer, same way, and karting micro game, that kind of stuff. You also have 2D mobile stuff and 3D mobile stuff. Again, all of these things, AR, VR, Lego micro game, all of these things you can do with these. These are just blank, and then these have stuff in them. That's the only difference. They're all free. If you want to goof around with them, feel free. If you really want to make a mobile game, you can either do it here or you can do it up here. It's however you want to do it. All right. Let's name our project. I'm going to name it Tutorial Unity. And let's click 3D. Let's create. All right. Does anyone have any questions, by the way, so far? If you don't, just send it a little thing into the tutorial chat. You don't have to unmute. Cool. Awesome. While Unity is loading up, I will let you guys know what we're going to be doing today. So we're going to be talking about the hierarchy, the scenes, the games, the inspector, the projects, the console, basically just a bunch of different tabs in this. We're also going to be talking about a bunch of different tool options, and then what is the core of Unity with game objects, components, materials, physics. Finally, scenes, and then scripts. And I'll even show you a really basic script you can use to kind of do whatever you want in Unity. Okay, all that out of the way. Let's get into this. So first off, the scene. So I'll just show you how this all works. So this is Unity. This is what it looks like. This is something that kind of blew me away, but this is the screen that professionals look at, just like this is the screen that you're looking at now. So you have now entered a tool that professionals use. Don't feel like, oh my gosh, this is dorky or, any of these things. This is a real tool. It's like an electric screwdriver. This is a real thing. This is the thing that professionals use and the people in between use. So don't feel like you're underclassed. You got this. You understand this. You understand everything. So there's a bunch of different tabs and screens around here that I'll get into in a second. But first, if you grab one of the tabs, you can reposition it however you want, which is really cool. And you can like stretch it and shrink it and do all that kind of stuff. So you can make this however you want to make it. You can set everything up in different ways. I know whenever I'm making games, I'll configure it in different ways depending on what I'm doing. If I'm playtesting it, I'll configure it in one way. And then if I'm like making it, I'll do it another way. So just know that it's super user friendly and you can do whatever you want in that sense. And I highly recommend it. In fact, you can actually, I won't go into this today, but there's other windows and tabs that you can have open that you can drag into wherever you want. So you could just put like every window and tab ever here. I wouldn't do that. It's very cluttered, but you could do it. Like for example, like move my inspector over there. And then I could move it up here. That kind of stuff. Cool. All right. So first, let's talk about the scene. So this is your scene in Unity right here. I'm just to make it easy to understand, I'm gonna quickly create it. I'll show you how to do that in a second, but go create a cube. Yeah, there you go. So this is the, I guess like, yeah, I mean it's the scene. It's the view of like the game's inner mechanics. So you can see where the camera is. The camera is never actually doesn't actually have an object in the world. Like if I turn off gizmos there, you can't see it, and you also can't see the light. However, it does exist. The engine recognizes there is a camera and there is a light source there. However, it doesn't physically exist. Similarly, this cube does exist. And if we want to look at it from the point of view of, okay, what do the players see? Then you go to this tab right here called Game. And there you go. That's what the players see. This is from the camera's point of view. We can move this forward a bunch. And now it's a lot closer. So that's how that works. And in fact, if you drag the game view over to here, then you can edit the scene. Wow. And you can see what it looks like. Look at that. Cool. All right. So that's the game in the scene view. It's very simple. Scene view, just go into some things. This is complicated. I've never really looked into it, but I know it has a purpose because I'm already seeing things that I wish I'd looked into earlier. We're not going to talk about this right now. You have 2D mode, which is seeing everything from a top or bottom point of view. I think this is the top view. So if you want to look at it that way, you can. See, like I said, 2D and 3D, totally not super different, but then you can just turn it back to 3D, so it doesn't matter. You have scene lighting. So basically it's like, do you want to have light turned on? Okay, let's do that. Audio, skybox, fog, and other effects. You can turn that off and on, all that kind of stuff. Hidden objects, all that stuff. Over here you have your gizmos. That's very simple. So gizmos is anything that you can't see. So that's like camera, light, that kind of stuff. So you can turn those off. It's also things like this has a collider with it, which I'll go into in a second. You can turn off the collider. You can't see the collider, that kind of stuff. All right. That is seen in game. Let's go into the next bit. So now you have over here on the left, you have your hierarchy. So hierarchy is very simple. It is the like spreadsheet of everything that is in the Unity scene. So right now we have a camera, which is right there. And if you double click, it will go straight to it like that. You have your direction light. And you have your cube that I put in. You might not have a cube, but I put in a cube. Your hierarchy is where you can see everything. You can do a lot with this, and we'll go into it more as we talk about game objects and components and materials. But this is your laundry list of everything that is in your world at any one time. And your hierarchy, especially when it's like a game and not just like a little thing like this or Flappy Bird, it can get pretty big, and that's okay. You just got to learn how to organize it, which we will get into once we get into game objects and all that kind of stuff. All right, next we have the inspector. Okay, over here. So you might notice that when I click on things, there's a bunch of stuff that comes up in the inspector. So the inspector is just whatever I click on, it gives everything that can be changed in this thing. So now let's get into, just for 1 second, no, we'll get into that with components and game objects. I don't want to make it too complicated right away. So the inspector is just, it says all the things I can change. So I can change the transform, which is its position, or like anything to do with its light. So what kind of light is it? Directional. Let's make it a spotlight, or we can make it a point light, which is like a light bulb. Directional light is like the sun. So it says the sun's coming from the direction it is listing. So that way. Cool. All these different things going on with light. I won't get into light right now because light's really complicated. So I won't, just won't talk about it for now. You also have over here a cube. You know, unlike, see, it doesn't have any light options on it because it is not a light source. So, you know, it has mesh renderers because it actually exists and it isn't just a blank piece of light. And a box collider, and then your camera has all the camera stuff and an audio listener, so it can like pick up on audio cues and whatnot. Yeah. So that's all there in the inspector. Next, you have your project file, which is right down here. This bottom part right here. So just to recap, you have your scene, your game, your hierarchy, and your inspector. And now we're into project. So this is just where all your files are kept. So this is where your scenes are. This is any packages you've downloaded. So like, do you have, I actually don't know what all these packages are. I won't get into, but they're things like TextMesh Pro and other, if you end up getting any asset packs and stuff, they'd probably be in packages. It's pre-made stuff. That's the way there you go. It's pre-made stuff. That's what it is. Such as things that interact with Visual Studio to let them know that Unity's doing stuff and all that kind of stuff. So it's just a bunch of pre-made things. That's all. You don't have to worry about it for 99% of projects. Assets. So assets is anything you drag into Unity. So for example, let me just pull up a little file here, and let's go to my GDC file. There you go. Boom. So you can just drag an image and it will go right in. There you go. See? And now we can drag this into the world, or we can drag it onto the face of this. Oop. And there it is. So assets are anything that you would use in Unity. So like, a cube is like a pre-made thing. Like Unity knows what a cube is, but it doesn't know what this image is. It's like, what the heck is this image? Well, there you go. Drag it in there, and then you can describe what it is to Unity. So that's pretty neat. And then the final thing we're going to get into is the console. So console is the list of commands. So as you can, let's get into this. How do you describe the console? I think that's the best way to say it. It's the list of commands, and you can debug with it really easily, which I'll get into when I get into scripting. It's basically just a list of text. And it will update with things that are happening in the game and what's going on. And it's just really useful for a lot of different things. It also will let you know if there's any errors, or if there's any hey, you have this Unity object, but it doesn't do anything. Like, why do you have a script, but the script doesn't have anything? Just that kind of alerts and errors and those kinds of things to let you know what's going on and to keep you working with it. I usually have mine on clear on play and clear on build, which I think is the auto setting. But if it isn't, I'd recommend putting that on. Basically, it means once you start the game, it clears out all the old errors, so you only see new errors. That's just really useful to have, in my opinion. You can collapse identical entries, and then you can just say, all right, we're gonna play, but just don't show me any of the errors, because I'm not looking for errors. I'm looking for debug stuff and that kind of stuff. So it's a really useful thing to know what is and how to use. So just to recap: scene, game. Oh, look, the cube's upside down. That's silly. Because it's looking at this side of the cube. We have inspector, hierarchy, project, and console. Cool. All right, now let's get into messing around with 3D objects. So you have a bunch of different tools at your disposal over here when you're messing around with 3D things. So first, you have your hand tool, which is just for dragging around the Unity scene, which should be said, to move around the Unity scene, you can click and drag with the hand tool, and then you can also right-click and turn like that. Usually what I do. You can also use the arrow keys. You cannot use the arrow keys and turn at the same time. I don't know why, but that is just a thing. Up here, you also have, you can snap to a certain direction. Okay, so we're looking perfectly down the x-axis, perfectly down the y-axis, perfectly down the z-axis, that kind of stuff. Ooh. You can also, if you are holding the look around, you can use W, A, and D to turn, but not arrow keys. So I don't know what's going on with that, but that is a thing. Next, you have the move tool, which means you can grab something and you can move it around. The red arrow is the x-axis, the blue arrow is the z-axis, and the green arrow is the y-axis. Y-axis is up and down, z is backwards and forwards, and then x is left to right, if you keep your camera in the normal placement. Otherwise, it would be different if I turn my camera around, or if I turn it to the left or to the right. But just know x and z are like walking around, and then y is like jumping and flying and verticality and all that kind of stuff. Cool. All right. Next, you have the rotate tool. Rotate tool. It's very simple. It lets you rotate. All that kind of stuff. And you can see how it's being rotated and moved by its transform in the inspector. So if you look at the rotation here while I rotate it, it's flipping around. And it's looking all weird and it's crazy. Yeah. I'm going to undo some stuff, Control Z style. But yeah, it's neat. Same thing happens when I move it. Next, you also have, this is the the scale tool. So if I want to scale it on the Z-axis, I can make it longer, or I can make it taller on the Y-axis, or I can make it thicker on the X-axis. Ooh, look at that guy. Boom, boom, boom. You also have the rect tool, which is just for rectangles, and it grows it evenly, or it grows it however you want it to, rather. So I can just be like, I want it to be about that big, right? And then you can go in and change it a little bit. You can just change the numbers directly here. For example, I can be like 2, that kind of stuff. But it's an easier tool for scaling and that whatnot. And then finally, you have your multi-tool. This is your positioning, it's your scaling, and it's your rotating all in one, but it can be confusing. So I mostly just stick with the position tool most of the time. And then I move around with WASD and the I, and the right click rather. So let's get back into this. All right, now we're on to game objects, components, all that stuff. We're about halfway done with the tutorial. Does anyone have any questions? If you don't have any questions, let me know in the chat. But does anyone have any questions? Feel free to ask them. Okay, cool. All right, we're going to keep going. All right. So next, game objects. Very simple. So at any point, you can right-click in your hierarchy, or you can right-click in your assets as well. Although if you're just doing something basic, I recommend the hierarchy, and you'll get this menu: cut, copy, all that kind of stuff. So you know what cut and copy is, all that stuff, and then paste. If you copy, you can paste, all that. You also have duplicate, super simple, delete, rename, that stuff all makes sense. Paste as child just means that you can copy and then I can paste it and it will be under it. It will be like connected to it, basically. So that's a thing. You have create empty parent, and then all this stuff. So I'll go into that now. So you have create empty. Very simple. So let's just create an empty. If you're trying to create something and you've already clicked on something else, it will create it as a child, just to let you know. So that's what that means. And parent is the opposite of child. It is above. So it's a very simple system on the hierarchy. Parents are the main thing, and then children are the smaller thing, and they're the thing inside the other thing. So that's simple system. Okay, so let's just create an empty. So empties are just a transform. They have nothing else connected to them. This guy's right here. Ooh, it's almost hard to figure out exactly where it is because it's just, it's like a one little dot in the universe right there. And we'll name this empty game object. Sure, I didn't erase game object, but that's fine. So it has a transform, which means it has a position, has a rotation, has a scale. The scale really doesn't mean anything unless there's something else connected to it. So it has a position and rotation, and that's kind of it. Right? It is one point in the universe. The idea of a point on a graph is just a dot because realistically it's so small you can't see it. That kind of idea. It is just one point that is infinitesimally small, and so you can't look at it because you can just zoom in on it forever. Your game can handle like a million of these. Empties are totally easy. Your game doesn't even need to think about them to render that they're there, right? So what I use empties for is as folders to keep my hierarchy organized. For example, this cube. All right, let's say we have like a bunch of these cubes. So I'm copying and pasting a bunch of them with Control C, Control V. If you're on a Mac, it will be done completely differently, but just like Command, I think is what it is. So now I have all these cubes. Let's pull all the cubes apart. Oh, there's one. Oh, there's another one. There's one up here now. So you got all these cubes. That's all the cubes, by the way. All right, well, I want to be able to, if I have a bunch of cubes and they're the same thing, I want to be able to keep them in line. So I'm going to rename this empty game object to cube holder. And then I'm going to put it at 0, 0, and I'll explain why that is in a second. And then I'm gonna control click, which lets you, or you can, that you can't, you can click and drag over here, although I wouldn't recommend that. I'd recommend doing things in the hierarchy because otherwise it's gross. But control click to click multiple things and then drag them all under the cube holder. And now the cube holder, let's say we want to move our cube holder 2 up, or 2 to the right or whatever. Everything moves with it, or 2 up there. That's cool. We might not never need to do that, but what's important is we can collapse it, and now we know that all of our cubes are there, but they're not clogging up the hierarchy. So it's a really good thing to be able to do. There you go. So now we have a cube holder. The reason you want to do it at 0, 0 is because, let's undo this really quick. So if you see its transform position is like, let's just make it fun to look at, not ugly. There you go. It's 1, 1, 1, right? So our cube holder is at 0, 0. Now if our cube holder was at like 2, 0, 0, and then we put this cube in there, now its transform position is not accurate to its real world position. So basically it's saying that it is -2 away from the transform. And the transform says it's 2 away, sorry, it's saying it's -1 away from the transform. And the transform is saying it is 2 away from the world's origin, 0, 0, 0, right? So now you have like 2 levels of complexity here. And that's really unnecessary. So if you're making a folder, always try to put things at 0, 0. But now look, if I put it at 0, 0 afterwards, it's moving there. So now where I wanted it, which is I wanted it at 1, is different. So I have to go in and change it again. So what's good to do is whenever you make a folder empty, just put it at 0, 0, 0 right away, and then put things in there. And make sure to do that because that's a common mistake I make, so I'm sure a bunch of other people make it too, where you make an empty that you want to have as the folder, and then it just isn't at 0, 0, 0. And then you have to reposition everything, and you're like, man, this sucks. Why did I do this? So please do that. I highly recommend it. Let's get the rest of the cubes in the cube holder so we can stop talking about them. All right. Now let's spawn other things in here. So we have our empty, and you also have the empty as parent. So, you know, you can kind of do that folder thing I was talking about earlier a little easier, although I usually wouldn't do that. It's up to you. You have 3D objects. So you have cubes, spheres, capsules, which are like pills or beans, as they're called in the game dev world, because they look like little beans. There you go. You also have cylinders. If you know your shapes, you should know a cylinder. A plane, which is a 2-dimensional object, because you look, it's blank on one side, and it has a position on the other, and it's infinitesimally small, just as the point is. So it's like paper thin, wafer thin. And then you have your quad, which is the exact same as a plane, except you can manipulate the corners a bit more. So it's not a perfect square. You can turn it into other things. It's a little different. It's not... I'd recommend sticking with planes for now, is what I'm trying to say. But yeah, you can change all the vertexes and everything and make it different. Let's see, convex. I don't want to make it convex. But yeah, there you go. Next, in 3D objects, you also have text. You have 3-dimensional text. You have ragdolls, terrain, trees, wind zone, 3D text. Oh, I don't want to do that. That was a mistake. What does a tree look like? I've never actually seen it. Is it just generic tree? It is. Weird. Huh. You put branches and stuff on that. That's weird. Everything after, I think, quad is a bunch of Unity preset stuff. I wouldn't screw around with it if you're trying to do your own thing. But you know, if you're new and you just want to see what everything does, do it. The text is good. Text is valid. But the rest of these are like preset things that you might need. You also have effects. We have particle systems, which are their own thing. We're not going to get into trails and lines. You have lights. You have directional, which is like sunlight. Point light, which is like a light bulb. Spotlight, which is a spotlight. Area light, which is like a ceiling light if you're at an office building. And then reflection probes and light probes, which are more complicated and I won't get into. You have audio, which is very simple. You have an audio source, which produces some form of audio, and then you have a reverb zone, which is like an echo. Like you can create zones of echo, which is cool. Video players. You can play videos in your thing. You know, you could have, like, for example, a cinematic, or maybe there's like a video, like camera feed, and you can put a video on that. It's cool. UI is its own thing I won't get into right now, at least, but it is exactly what it sounds like. It's the stuff that's plastered on your screen, and you can create different UI canvases for all this. It's its own thing. It is big deal. And then camera, which is exactly what it sounds like. So if you want to create a 3D object, you would just go 3D object, cube, and now there's a cube in the world. And I'm going to give it its little, there you go. It's exactly the same as the other cubes now. And I'm going to put it in the cube holder. Boop. It is held. All right, components. All right, so something you might notice is, like, what would be the point of an empty? Empties can't do anything. Why would I ever make an empty? Well, you have components. So every object in Unity is essentially just an empty. Let's get rid of this. I don't know what that is. It's because I spawned in the tree in the terrain. Look, this is the problems you run into. All right, let's get rid of that. Cool. All right. Every object in Unity is just an empty, except, oh, prom dresses, cool garage ideas, neat. Every object in Unity is just an empty, but it has components added onto it. So, for example, this cube. Cool. This cube, it is an empty. It is just a transform. However, it has a cube mesh filter, a mesh render, and a box collider, and a material. And so that's what makes it look like a cube and not just an empty. But all things in Unity are empties, including this light. This light is literally just an empty with a light component. And then a camera is just an empty with a camera component. And in this case, an audio listener as well. So, like, for example, let's say I wanted to make a new light. I could just type in light into this little search. And boom, now I have a light. It's just exactly, it's a brand new light. Look at that. Oh no, I added the cube holder. No. I want it in this empty. Cool. Bam. Now there's a light there. We can make it really intense too. We'll do it right there. Oh, look at that. It's like really making that the way it is. Let's turn the intensity up to like 100. Oh, it's blinding. Look at that. And we can turn the color to like red. Oh, that's so crazy looking. Intense. Anyway. It's the fun things you can do in Unity, right? Cool. So yeah, now it's a light just like the other one is a light. It's as light as that is a light. The only difference is that we made it ourselves raw instead of just spawning in like the preset template of what a light is. And so that's true with everything. So for example, there's a lot of different components you can use. You can make it have 2D, so you can give it a collider. And there's all these different kinds of colliders and other physics joints. So you can give it like a fixed joint. You can do a distance joint or friction or hinges. So that's like a door. You can make it a polygon collider. You can give it a rigid body, which is lets it be affected by gravity and physics. So like a collider is like it's stopped, right? Like these things run into each other and they detect each other. But a rigid body gives it physics. So I run into you and then you go flying, that kind of stuff. And if I don't have physics, then I'm fine. So it's a really interesting situation there. You can mess around with physics, and I'm sure that's more complicated than anyone cares about. You have 2D physics, you have 3D physics. The difference is that one is two-dimensional, one is three-dimensional. That is it. 2D physics will make it so you don't go up and down, but you do go left and right. And then regular physics says you go up, down, and left, right. That's the difference. You have tile maps, you have UI, you have all this kind of stuff. So even the elements that I was mentioning that are complicated, like all the UI elements, they are just transforms with components like everything else. In fact, I think they use a special kind of transform. They use like a rect transform. But nonetheless, super simple. Right? In fact, if we really wanted to, watch this, get rid of my cube holder. I can get rid of this. Actually, I don't think I can. Never mind, I lied. I can't get rid of the transform. But I could get rid of, like, for example, this collider. I can say remove component, boop, and now it can't collide with anything. It's unnecessary, so I won't go into that right now. Cool. Components, game objects. That's how it all works. Next, we're going to do materials, and then I already did physics, so that's fine. We'll do materials, and then we'll do scenes and scripts, and then we're done. Does anyone have any questions? If you have no light objects, will the scene be in utter darkness once the game is running? Just to prove, yes. You do have generic scene light, but you can turn that off. Sorry, no, no, no. The answer is yes, but there is a skybox that is creating some light for us right now. A lot, depending on, this is a sprite, so the sprite's always going to have color, but like, for example, if I took away this, oh no, because if I did that, then everything would be mad at me. If I gave it a new material, let's say, so let's go to scene, and let's give this a new material, like that, yeah, there you go. And it would be pretty dark is the answer. Yes, to my knowledge, let's play. Yeah, no, I can't. It is playing. It's just that there's no mechanics. Oops. Yes, it would be like pitch black. Good question. Cool. Let's get the light back. All right. So let's go to materials and then scripts and scenes. So materials is what I've done here. So whenever I dragged this image onto this cube, I have made a new material. So whenever you make a material, it will get rid of this. I don't want the tree texture. Whenever you make a material, it will go right over here, and it will make a file called materials for you. So usually you're going to get a ton of material files all over your thing, so you need to like keep those organized. Organization is key in this field. And in the inspector, when you click on a material down here, you can see all of this stuff. Don't worry about it. Super simple. All you really need to know is the albedo, or albedo, whatever how you say it. I always, in my head, I call it albedo, but looking at it, that is definitely not how it's pronounced. The metallic and the smoothness. Those are the real things you need to worry about. And then emission if you want it to glow, but it's not, you know, that kind of stuff that's a little more complicated. And then if you really want to get into making things look really pretty and in 3D, because materials are really only used in 3D, then, you know, look into this more, go to YouTube tutorials. But for me personally, I have only ever found the albedo, metallic, and smoothness. So albedo is what color, like it is like superimposed on top of it, right? So you can make everything just pitch black, or you can keep it white, which is its normal. So basically no color is imposed on it. But you can create it like it's a little dark. And so it has all your colors, but just with a red tint to it. So that's that. And then you have metallic, which is how much light does this absorb, right? And then you have smoothness, which is how much light does it reflect. And if it reflects all light, which is 1, and it absorbs all light, which is 1, it is very, very, very dark. And it looks almost like 1 smoothness is like a mirror. So, you know, that might not be the way you want to do it. And then metallic is like, it is dark as well as being a mirror. So if we take all the smoothness out, it just doesn't reflect light very well. So if it's just metallic, let's grab a point light and stick it up its nose. So we'll do this, yeah. Ooh. So see, let's turn it up to intensity 10. Oh, that's very bright, right? Okay, as I turn down the metallic, it's going to get brighter because it reflects, it absorbs less and less light until it gets really blurry at the end. So metal surfaces in the real world they don't always have one perfect reflectiveness, but they are quite reflective. So that's something, you know, like it basically says, could you put a really bright light to this and still see the details of it? That's the idea. Smoothness is the opposite. So if something's really smooth, how well does it reflect it? So let's move this up. There you go. It's like right on top of it now. And then you can see with the metallicness. Yeah, see, it's still good. So smoothness is how good does it reflect? And if it reflects perfectly, it's going to look like a little dot. See? Little dot of like where the light is, right? But the less perfect it reflects, the more it bounces around. And so that little dot will get bigger and bigger and bigger until eventually it's, you know, really, really, really bright on the thing, because it's not good at reflecting. Like I said, 1 smoothness is essentially a mirror, and so that would be what that is for. And then I usually make, like, for example, bathroom tile, I usually make a little smoother, and then I usually make metal surfaces pretty smooth, although not every metal surface is smooth. And then also you would make metal things like bone, right? Bone would usually be pretty metallic when it comes to this, because it doesn't reflect light perfectly. And then it's not very smooth either, because like you think of bones as being smooth, but they're really not, and they don't reflect light particularly well. They absorb a lot of light and don't reflect a lot, and so that's its own thing there. Cool. All right, so now that's materials. You can make materials. You can go here. You can create some things in the project that you can't create in the hierarchy, I should have said. So for example, here you can say create, and you get an even longer list of things. You can get all the things you got before, and then you can also get like scripts and prefabs, which I'll go into actually in a second. You also get materials, lens flares, render textures, light mapping, all that kind of stuff, animations, all that nonsense. Cool. Let's get into prefabs. Prefabs are pretty simple. So this cube, I've used this cube a lot. This is like my top tier cube. This is the cube that separates the boys and the men. This is the cube right here. Okay, cool. I want to be able to just, whenever I spawn in, like I want to be able to just grab this cube and throw it into a scene, right? So like, for example, let's say that instead of this cube, this is like an enemy, right? So if we're talking about Minecraft again, this is the zombie, right? So zombies have their own AI, they have all their own stuff, they have all this complicated parts to them. I don't want to have to remake it or just copy paste it every time. And sometimes I can't copy paste it because there might not be a zombie in the world to copy paste, right? Currently. So how do I do that? Well, first you grab this, you drag it down here, all of a sudden you have a cube, and I can name this to anything I want. We're going to call it prefab cube. Rename. Cool. And then this is like a special editor where you can like come in and just change it, right? And then if I want to drag another cube, let's grab, there you go. It's perfect. It comes out exactly the way I expected it to. Just like the other cube. And if you go in here now, first off, let me grab all these and put them in the cube holder. Now if I go in here and let's say I take off the material and I turn it back into a regular cube. Now, oh, these cubes are copy pasted, so I think they're technically counted as prefabs. So let's change that up a little bit just to show you the difference of them. Cube. There you go. So, and now if I come in here and I add this material to the cube, they'll have it, and then when I come in here and I take away that material, reset, only the prefabs lose the material. So that's a cool thing where you can like edit your prefabs and it changes everything. So like that example would be like an enemy or like a trap or maybe a tile, like if you had like a special tile that like makes you jump higher when you step on it, like a platformer. And you're like, ooh, that doesn't work. Instead of having to go and like going in and like changing each one individually, you just change the prefab and then it changes everything across the whole everything. So it changes all of that versions of that thing. So that's pretty cool. Good little thing to have in your pocket. Something I also use prefabs for is bullets. So if it's a bullet, you're going to spawn the same bullet a million times, right? So you just prefab the bullet, and there you go. You're good. Now, whenever you're writing up the script and stuff, you just say instantiate bullet, because that's the other thing that prefabs can do is you can throw them into a script. So whenever you're writing a script, you could say, oh, the game engine now knows what a prefab cube is, right? So like it knows what the GDC cube is, what I could call it. I could call it the GDC cube. So it knows what a GDC cube is. So whenever I press space, I want you to spawn a GDC cube right in front of me. And it's like, cool, I can do that because I know what that is now. That's the benefit of a prefab. All right, let's get into the final bits here. So first we have scenes, which is this. So scene is everything in your hierarchy. It is kept inside the scene. And actually, I'm going to save the scene right here. Save. And it is everything here as well. So this is the actual scene, as it says right here. An example of different scenes would be you might have one scene for your main menu, and then another scene for level 1, and then another scene for level 2, and that kind of stuff. So you could, let's say, new scene, and we'll do empty. Yeah, we could do the basic scene, which just has the camera and the light. But let's do empty. Let's do empty. There you go. Totally blank. And if we wanted to, we can go back and we can open scene, scenes, and you can go to sample scene. And now we go back to where we were. So that was the difference between the main menu and this scene and this level 1 here. That's how that works. Cool. Scenes are useful. You're gonna have if you have a big game, you're gonna have a frick ton of scenes. If you have a small game, you might only have. I mean, I know a lot of games only have 1 scene. I can think of a bunch that probably have 2. And then there's a bunch of games I know which are small games, but they have like 30 scenes because they're just organized that way. And that's okay. There's no problem. Your game can hold scenes. Scenes are like folders, right? So you can have a ton of them. It doesn't matter. But it's just how you organize things. Okay, scripts. Final thing here that we're going to be talking about today, scripts. Create C# script. Before I go into this, does anyone have any questions? Also, hi Ambron, hi Joey, Sty, you guys are cool. Thank you for joining. All of this is recorded, so I'll send it and all that kind of stuff when it's done. In fact, how's the recording going? Oh, it's recording everything. Perfect. All right. Cool. All right, we're good. No questions. Awesome. So, new behavior. Let's see. All right, so we'll call this, you should really name, let me delete this. Whenever you're doing scripts, you have to name your script the name you want it to be right away. You can rename it, it's just kind of annoying. So let's name this right. We'll call it GDC script, because why not? Cool. All right, and then we double click this and it's gonna pull up, I haven't clicked yet, but it's going to pull up also you can see in the inspector all the code written out like that. That's a thing. If I double click this, it will pull it up in whatever code analyzer thing that you have, right? So I use Visual Studio. I think Visual Studio is probably my favorite out of the ones I've tried to use. I recommend it. It is free. However, if you want to use something else, that's totally fine. Just have it be your preset on your computer of like, hey, anytime I open up a code file, open it up in this, right? I got Visual Studio. I started using it for Minecraft files because I used to make texture packs in mod Minecraft. So that's what I used to use it for, and then now I'm using it for this. So loading it up, Visual Studio 2019, because I'm old and I refuse to accept new editions of things. It does usually, Visual Studio does take a second to load up the first time, but once you have it loaded up, you can create a new script and it will just automatically go into it right away. Just don't close it. If you close it, it will take a second to load back up. That is the lesson I learned the hard way. So, there we go. Okay, it's in. And let's zoom in because, man, that is so zoomed out. There we go. You can just, normal control scroll to zoom in. And then to give you an example, let's create a new script and we'll call this one script 2. And then it will loading. Okay, and then script 2. And there you go, it's right away. So it only has to load that first time. Cool. All right, so what's going on here? Nothing crazy. So this is a mono behavior. What that means is you attach it to an object in the game, and that object will be affected by the script. That's it. It's super simple. So for example, let's say let's actually make a script, and I'll show you how that works. You can also get other kinds of scripts, like you can get static scripts that just kind of hold information. Like for example, in my game Void Slugger, which I made in Unity, you had an accuracy tracker, right? So like every shot you fired, if it hit or if it missed, right? So you could see like, oh, I had 73% accuracy this run and 80% accuracy of all my runs put together, that kind of stuff, because it's like a roguelike. That would be a static script because that number is just kind of being kept outside of it, outside of like an object. It's just something that the game needs to be able to reference, right? Something else that could be a static script could be I don't know if it should be, but it could be. A like a score. Score might be static. I wouldn't make it. I would make it an object, but like that kind of stuff. Or if here's something that would be static. If you had a grid because you're doing grid-based combat, which I've screwed around with a couple times. It's fun, but it's a little annoying because you gotta think of it in a different way than what you think. It is you would have a grid keeping like script. Like this is the script that makes the grid, and it would generate it would activate a different script to generate the grid, and then it would know what is in every tile at every second. So like, okay, this tile 03 11 has this kind of cover, and then this tile 04 99 has this enemy in there, and he's looking, and and then it can access the enemy script and say, okay, the enemy's looking this way and it's doing these things, that kind of stuff. So that'd be like a static script. We also have mono behaviors. Okay, so you can press enter and then tab to go forward, and then backspace a couple times to go back. Let's look at what this is. So first, this green text. First we should look at the name. So you have your name, which is GDC script. This is the same name as it is in Unity, GDC script, except it does not have a space, which is why I super recommend that if you name a script, do not use a space in the name like I just did. Use underscores or something, because it just makes everything more complicated, and it is a waste of everyone's time. Cool. Just letting you know ahead of time. That's the name. It's a public class. Don't worry about that. Mono behavior. And then up here you have what is it using. So using system collections, generic, and Unity engine. What that means is these are things like if and statements right here. And it's saying, hey, you're using if and statements and all that kind of stuff in this. You need to have these things in so it knows what an if and statement means. If that's the way to, it's kind of like saying, think of them like code books, right? So like I'm writing in like a code, like just gibberish, right? And the computer needs to know what code book to look at to translate what I'm writing into like things that it can do. So you're saying, look at system collections and system collections generic to see what I'm doing. Similarly, Unity engine. When you're interpreting this code, use Unity things, because I'm going to be referring to Unity things in this. And I need you to understand what I'm talking about. That's the idea. Okay, so we have a couple things here. So first, the green text. Green text doesn't do anything. If you double / and then type whatever you want, nothing happens. It's basically comments, and I highly recommend you make your code highly annotated, which means there's a lot of comments in it, because it keeps you on track. Because you get these, like, you will get scripts, and you won't even realize you're doing this until it's too late, that are like 1,000 lines of code, right? Because, and it's not always because every line is like filled, it's not like you're writing a book, right? It's not like every line is filled. It's that a couple lines have like 1 or 2 words in them, and then you press enter a couple times to keep things organized, and da-da-da-da. Anyway, you get 1,000 lines, and that is just really annoying to parse through. And you'll get lost very easily, especially if you come back to the project after a long period of time. So it's very annoying, and you need to know what's going on, because you can't just, you will not be able to, I promise you, look back at your 1,000 lines of code and figure out what everything does without spending hours of doing it, even with some annotation. So if it's heavily annotated, maybe you'll understand what's happening, but annotate all the time. It's a problem that I have. I don't annotate enough. I'm telling you, because you're new, please learn to annotate your code. It is so useful. Okay, cool. Next we have void start and void update. These are pretty simple, and then you have some brackets. You have some parentheses and some brackets. Okay. So void, I don't know what that means. It's a thing you write down. I don't know what that means. I'm sorry, I'm not a coding guy. I'm actually a history major. So, it's what it is. And then you have start and update. And the green text here, which is at the beginning of every script, tells you what they do. You can get rid of these. Your script does not require to have a start or an update function, but just they're there because a lot of scripts have them. So it's a good thing to just have generically. So start is called before the first frame update. So as soon as this script is activated, start happens. actually technically before the script is activated, start happens. Start has to occur before the script will activate itself. So it could be things like, for example, if I want to move forward, right? And the way I move forward is I have physics. So I want to move forward. I want to put force on my rigid body. So it pushes me forward, right? That's what that means. It pushes me forward. And I don't know, the computer doesn't know what rigid body you're talking about. It doesn't know that you mean this guy. You could mean the guy to your left. It could mean the guy to your right. So it's not going to do anything until you give it really specific instructions. So what you would have is this variable, and it's called, right? So I'll put this in. I'll put rigid body, and then so that's we'll do 2D just to show you. There's really no difference, but we'll do it. Why not? So you go, and this is going to be a private rigid body 2D, and then you name it. So let's name it John because I want to. And so then we'll do something like this. We would say, so anytime I write John from now on, it knows that that is rigid body 2D. It is referring to this specific rigid body, right? So John equals this dot get, no, not John, get component rigid body 2D, semicolon. At the end of every line of code, you want to put a semicolon. That just basically ends the line. It says, okay, go to the next thing, stop reading it. So what I just did is this. I said private. So private means that when I look at the code from the inspector, so for example, let me save this. Actually, let's not make this a 2D. Let's make it a 3D because the cubes won't have 2D things because they're 3D objects. So let's say, where's cube? There you go. And let's stick GDC script on there. Can't add component GDC because script class can't. Oh, yeah, we need to change the name, shouldn't we? It's all mad at me now. It's like, oh no, what are you doing? Yeah, see, like I said, don't put spaces in your things. It just makes things complicated. Don't look at it. It's bad. Cool. Okay, it's happy with me now. Let's see. There we go. So because I have a private variable, you won't see it here. But if I make it public, so let's say, we'll just say it's public for the sake of it. Public. And then you click on Unity to get it to update. You click on this. Bam, John, rigid body, none. So you have that you can see it. And that's useful for a lot of things. Like for example, if you're playing the game and you have, your character's like, okay, what's the momentum here? How many bullets do I have? That kind of stuff. You might want to make it public just so you can see it. And you can, while you're the game is going on one side. So I have the game over here playing, and then my scene and my guy's moving around. I want to be able to see all that information. You might do it that way. Another reason you might put it in public is because if it's public, that means other scripts can access it. So for example, your health, your character's hit points will probably be public because when another script punches that character, it needs to be able to damage the hit points, that kind of stuff. And there's ways around that. You can keep the hit points private to keep things from just getting I know I did this when I first made my game. I just said, I'm new, everything's going to be public because I don't understand things. And it became really disorganized, but I was new, so I didn't understand things. And I just had one script that had 50 variables that you could see, and it was you couldn't parse through it at all. It was totally unreadable, but it was what it was. You could do it that way, and there's no problem with that. So anyway, we'll just keep it public for now. So rigid body, John. So what this is so that's public or private. That's what it is. It says it is a rigid body, and then that's the name, and then that's it. The little semicolon says stop looking at me. So what I wrote down here is John, which is this rigid body, equals this get component rigid body. So what that means is this, as in the object that this is attached to, get component. So that means go into that object and get a specific component, and then in these little I don't know what those are called, arrow things. You're looking for that specific component. Okay, I want to get the rigid body, right? Because presumably it's only going to have one. If it has more than one, you might screw it up. So don't give it more than one. I don't know how you would do that. I mean, it's only got one set of physics on it, unless you want it like no, you would never do that. Don't do that. And then this over here is like any excess information you might need, which is for really complicated coding. I wouldn't worry about it. But you need to put the parentheses because that's just the way it's written. Same thing with startup here. It's written that way. That's how you do it. Okay. So now, if I give this a rigid body, and then I press play. First off, it's going to fall into the abyss and disappear forever. There you go. But it automatically grabbed it. It said, oh, there it is, the cube rigid body. And if you don't like coding and coding isn't your thing, one sec. If you know a lot of okay, you can install Visual Studio along with Unity install. That's true, you can, and I highly recommend it. Okay, so yeah, if you don't like coding, we'll go into like other ways you can get around it, but that's super basic, right? Okay, so now let's think of another thing here. First off, it is going to have no gravity because I don't want to be affected by gravity. So now we can do this, and it should stay still. There you go. Yeah, it's still. Awesome. Okay. Now we get update. So update is called once per frame. So there are multiple frames a second. You know, usually people look for like 60 FPS. So that means every second there are 60 frames or 120. Most consoles do 30, I believe. That kind of stuff. So normally 60 is what you're looking at for frames per second. So point is, it happens multiple times a second. Okay. So what we can do is we can make an if statement. If, oh, how do you write this? Input dot get key. Yeah, we'll do get key, and then key code. Key code. I think it's we'll do. Why am I struggling here? S. Thank you. And then brackets. Okay, so what I've just written is this. If I put the key, if I press the key S, so it says input, there's going to be an input, right? So something's going to happen. It's going to be a key, get key. Okay, there's going to be a key involved. All right, it's going to be on the keyboard. It's not going to be mouse. It's the keyboard. All right, key code, which means, okay, this is the specific key that we're talking about here. I'm ready. S. Okay, so if I press S, that's what if all that stuff means. We can do, I haven't done any force stuff in a while. John, add force. It's a vector 3. Okay. New vector 3. And then another parentheses. And I'll explain what all this means in a second. So we do 0, minus 100, 0. Cool. So what I just said was, on John, which is our rigid body, add force, which is to say like apply force, along this vector. So vector is just like, all right, let's find a way to describe this. I think it'd be best to look at it in Unity. So if I go back to the scene view, your vectors are the arrows. And if you do a negative on an arrow, it'll be the other side of the arrow. So like if I go plus Z, it'd go this way. If I do minus Z, it would go this way. And then plus X, minus X, plus Y, minus Y. And then it's just written X, Y, Z. So, okay, that means whenever I press S, it should go down. It should apply negative 100 force to this thing. I don't know what that's going to look like. It might shoot down, might float down. I haven't messed around with forces in a while. So let's look at what's going to happen here. All right. Oh, it's gone. Oh, that's funny. All right, let's try that again. Maybe a little softer. And there's no friction because there's no gravity. It's not rubbing up against anything. So it should just exponentially get faster the longer I hold it. So let's see. Oop. Oh, there it goes. Cool. And then I can do the same over here. So let's do that again, but with W. And we'll have it apply force up. And so it should be said get key. So there are multiple different get key options. There was down and there was up. The difference is this. So get key means you can hold the key. Get key down means it only counts when you press the key down originally. So you have to press the key multiple times to keep applying stuff. And then get key up means only when you release the key. So that's what those mean. And we can get into that in a second. So okay, S and W. Let's do this. All right. Load, boy. Thank you. Oh, no, I clicked it twice. And then let's go down a bit. Oh, there he goes. And it's trying to cancel out the forces there. Okay. There you go. Look at that. Isn't that nice? Oh, a little floating up and down cube using S and W. And I can hold it. And it'll just go boom and come back and go boom. That's so neat. Come back up, friend. Stop. There we go. Yep. All right. There you go. That is your Unity tutorial. That was about an hour, I think. If anybody has any questions, let me know. Can we also see what the game does if S is held? Yes, we can. It just went shooting straight down. So, and let's see. How about this? We'll see what happens whenever we hold both of them at the same time. Let's see what happens. You ready? Let's try to even it out. Okay. Nothing, because it's applying forces at the same time. But as soon as I let them go, there you go. Boom, boom, boom. That's so cool. I love it. Honestly, I love doing game stuff just because you can screw around with the physics. And then let's do this just to show you guys what would happen here. I know I said that was the end, but I'm going to do this because it's fun. D. And we'll do A. I think it's -1. I hope so. If it's not, we'll just change it around. And then we'll do 1. Hopefully that gets everyone moving the right direction, but I can't be bothered to check. So, yeah, that's right. Oh, look at that. Now it's moving up, down, all around. Woo! Yep, and that's all the code you need to get this happening. Cool, guys. Well, I think that's it for now. Oh, that's so neat. I don't know why it's fun to move this box around like this. It's got a lot of weight to it, actually. Which reminds me, we can get into, if you want to change the mass over here, I'm going to change it to like 0.2, so it's going to be way nippier and flying around and whatnot. Let's see how's it. Whoa, whoa, whoa. Oh my gosh, it's spinning. I think it hit something. Cool. Neat. There you guys go. All right, I'm going to turn off the recording. If anybody has, actually, if anyone has any other questions, let me know now. And then I'm going to turn off the recording if there are no other questions. Okay. Cool. All right. And then everyone can mute yourselves. Let's talk about this.